So for these examples, it gives us the polynomial equation, and we have to figure out those zeros or those solutions to actually plot on our x-axis. So it's already factored, so we don't have to do that at least. Since it's in factored form, we can set each one of these factors equal to 0 and solve for them. So, for instance, x minus 1, if you guys set x minus 1 equal to 0, you'd add the 1 over, and x would equal 1. Over here, if you set x plus 2 equal to 0, you'd subtract the 2, x would be negative 2. Over here, negative x squared, we would divide by negative. 0 divided by anything is still 0. So you get x squared equals 0. Take the square root, and you'd still end up with x equaling 0. So those are your three solutions or zeros to this polynomial equation. So what I'm going to do, because we have to plug in values to find the positive and negative intervals, like on that first page, it was done for you. So we've got the numbers negative 2, 0, and 1. So we had to plug in a number between each of these values and figure out if the polynomial would end up being negative or positive. So I'm going to plug in, you can plug in anything less than negative 2. So I'm going to plug in negative 3. So anywhere that you guys see an x, you guys are going to plug in the value negative 3. So negative 3, negative 3, negative 3. So here's the deal. This is going to be on the non-calculator portion. Like, we want to know that you guys can do this without plugging it into your calculator. So I don't actually care what the value number is. I just care if it's going to be a negative or a positive. So if we look at this, anything squared is always positive. So like negative 3 squared would be positive 9. But then when you multiply it by that negative, that whole section is going to be negative. So then you look at the next section. Negative 3 minus 1 is negative 4. So that would be a negative. Negative 3 plus 2 would be negative 1, but anything squared will be positive. So what happens is you can kind of look at these as negative 1, and positive 1. I don't care what the actual number value is, but I know that a negative times a negative is going to give me a positive value. Times that positive at the end means that the whole section will be a positive number. I don't know what the number is. I don't care. But I know that it will be positive. So then we need to plug in a number in between negative 2 and 0. The easiest one I can think of is negative 1. So negative 1 squared times negative 1 minus 1 times negative 1 plus 2 squared. So negative 1 squared is positive, but times that negative in the front is going to give us a negative value. Negative 1 minus 1 is negative 2, so there's another negative. And negative 1 plus 2 would be positive, but still, anything squared is going to be positive. So this last section, this last number should always be positive, because no matter what it is, you're going to square it. So negative times a negative is a positive, times a positive means that that section will also be a positive one. So then something in between 0 and 1, I'm just going to plug in 0.5. So negative 0.5 squared times 0.5 minus 1 times 0.5 plus 2 squared. So again, I don't know what 0.5 squared is, but I know that anything squared is positive, and then times that negative will be a negative. So you also should be noticing that that first value is always negative. Okay, 0.5 minus 1 is still a negative. And then anything squared at the end is going to be positive. So this section also will be positive. So then we have to plug in one more value. Something greater than 1. So you could plug in 600 for all I care. As long as it's larger than 1, we'll just plug in 2. So negative 2 squared times 2 minus 1 times 2 plus 2 squared. Again, that first section, 2 squared is 4, which is positive, but times that negative is going to give you a negative value. 2 minus 1 is 1, so that one is positive. And that last section, 2 plus 2 is 4, but 4 squared will be positive. So, positive and a negative. So negative times positive is a negative, times that positive, this last section, is actually going to be negative. So on your graph, let's plot the zeros, negative 2, 0, and 1. And after plugging those values in, we know that it's actually positive from the left to negative 2, negative 2 to 1, 1 to 0, and then from 1 onward is that actually the only part that's below the x-axis. So when you're doing this, once you guys get these negative and positive signs, what happens is an even number of negatives means, like a negative times negative, means the whole interval will be positive. If you have an odd number of negatives, your whole interval is going to be negative. So if you can figure out which parts are negative and which parts are positive, if you can figure out that part, then you know even numbers keeps that interval positive. Odd numbers, so like say you had 1 negative or 3 negatives or 5 negatives, then that interval would be negative. Also take notice that your roots of negative 2 and 0 are double roots. So, what two values are squared? 0 and negative 2. So that's a good way also to check that your graph is correct. We also know that the lead coefficient in this problem is negative. Our polynomial does end going down. Another thing to check. We can also count the degree. X squared times x is x cubed times x squared. This would be an x to the 5th polynomial. Odd power means your ends go different directions. Another good check. So there are multiple ways to check without a calculator that you have drawn this correctly using all the tools that we've learned.